Good morning, good afternoon, good evening. It's time for another episode of Train Talk from Milepost 141. This is the SoundTraxx Sound Bites podcast. And yes, we're back at the office here after the holidays. And so we're really excited. This year, we actually celebrate 35 years of SoundTraxx being a company. And that's right. We were one of the industry pioneers when it came to sound and DCC technology. We were there in day one when the DCC meetings were going on. And so we were able to take what was a DCC signal and see what its potential was and be able to move forward and deliver you all the great sounds that everything is out there in the world today is all pioneered by us. And the good news is we continue to innovate. And so we have our Blunami, which I've got a couple of projects here that I was working on over the holidays, and I'll show you those here in just a little bit. But wanted to get back to just a couple of things when it comes to working on decoders and building decoders. And what does that entail? So when we build a decoder, I want to talk a little bit about just what goes into making a decoder and kind of, looking back in our history of what we've done and how we've done things over the past to help bring you such good quality products that we have all this time. So when we look at a decoder, we say, okay, what do we want it to do? And we create a spec. This is kind of a whole list of all the things that we want the decoder to do, whether it's being able to light up a simple command is being able to light up the headlight, or if we want to have the sounds of the diesel engine respond to the load on the motor. There's a whole list of specs and things that we want the decoder to do that we'll put together into a full document. Then we'll kind of organize that into groups. For example, sound features, light features, motor control settings, things like that. And then we start to build a project. And so from there, then the software engineers start to code the new software. Then we also look at what is available in the world as far as, our audio library, what's out there that we don't have, things like that. And so any new recordings, anything like that, we start going out and making those recording trips so that we can go out there and load these decoders with as many sound files as we possibly can. Again, we're trying to deliver you a sound simulation project as opposed to just a random noisemaker. You can go to a grocery store and open up a greeting card and it plays sound. Anybody can make noise. But the way we try to do our decoders is so that a lot of the sounds are interactive, again, based on the way you use your decoder, because we're trying to give you that simulation experience. So our software engineers start to work, the audio engineers go to work on getting new recordings and remastering old ones, things like that, making sure the quality is going to be there. Then we have our hardware engineers that will actually go through and try to find specs of processors, audio amplifiers, things like that will deliver what we want. So for example, when we went from the original Tsunami to the Tsunami 2, one of the biggest customer requests was to make it louder. And kind of the philosophy, when we had started with the original Tsunami, we had mixed all the sounds more or less at the even audio volume levels inside the decoder's memory, and then the amplifier would play those, and it was up to you as the user to move the whistle a little louder or the horn, the bell, and adjust those accordingly. But overwhelmingly, a lot of people were asking for more volume overall. Because sometimes the horn wasn't completely drowned out, but it kind of was hidden a little bit by the sound of the prime mover. And we've done this before. We've talked about the frequency spectrums when it comes to speakers that we're going to be putting into our small locomotives. So that's something you can always go back and take a look at. If you watch webinar 5 on our YouTube channel, you can kind of get a feel for all of that. But we went through and we go and the audio amplifier, or the hardware engineer then goes through, finds an amplifier that's going to be able to deliver the audio quality that we're looking for. We also look for processors that are going to be capable to handle all of the tasks that we want the decoder to do. And in addition to all of that, it's not just picking out parts and throwing them on a board. They have to make sure of the manufacturability, because as many of you know, we actually manufacture here in Durango, Colorado. And if any of you ever do come out and visit to ride the Durango and Silverton Railroad, you're always welcome to come out and contact us, and we'll be happy to give you a tour. We're proud of what we do. But when it comes to the manufacturability, we have to make sure that the parts that we select not only are able to be done with our machines, but also we have to organize them in such a way that the machine, when you're putting parts on there, aren't going to knock other parts off. Because if you go back to see the factory tours we've done in the past, you'll see that the parts are put on and there's a solder paste, which is a tacky substance similar to toothpaste that holds the parts in, and then when it runs through the oven, that's when all those solder joints are made with that solder paste. But what happens is if there's a part that's, a large part and then a small part has to go on the other side of it, the robotic arm can actually knock and move things away. So they have to plan all that kind of stuff out accordingly. So as the software engineers work through different modules of what we want the decoder to do, then they'll actually work through and make sure the audio circuitry is able to handle it, the processor is able to handle it, and so forth. And once we put all of that together, that's when we build a decoder. And again, of course, everybody wants it smaller, right? So we're trying to find ways to make it smaller, fit in specific footprints, things like that. Once a new product, let's say, for example, when we went from the original Tsunami to Tsunami 2, then the engineering team will actually come up with a finished product. They've got test boards, they've got test procedures and things like that, and they come to us in the sales department and they say, here, take a test drive of this and make sure that A, it does what we expect it to do, B, it does what it's supposed to do, which should be the same thing, but also to make sure that the software doesn't change something. So like, say, for example, if we set a CV setting in our decoders that could change the behavior, it doesn't break something else in the process. And then also to make sure sound files, things like that. And then there's also safeguards built into the software so that, like, say, for example, on these diesel decoders here, you've got 44 different air horns to choose from. Well, if our customers accidentally do it, and I've done it, I've been guilty of it myself, but accidentally hit the wrong button and accidentally choose whistle number 58 instead of 28, let's say, then that could put the decoder into some sort of a vapor lock where it's looking for data on whistle or air horn 58 that doesn't exist, but it can't move on until it gets that data. So we test all those safety measures to make sure that when the decoder is built and you get it, you don't have a whole bunch of booby traps waiting for you to find by accidentally putting the wrong CV value. So what that does, it gives you the confidence to be able to go in and experiment and try things out. But that's not what this is about. This is about the production and development. So what they'll do is they'll give me a decoder, and they'll say, and a test manual. And that test manual is usually about inch and a half thick. And what then we get to do is we go through that manual page by page, which goes through the decoder CV by CV to make sure that every CV value works and that every CV value or whatever does what it's supposed to do, and like I said, doesn't break something else in the process. And so even if we get to the point where we get to the end, we open up and we find something on the last page, the software engineers go, yep, found a bug. They'll go through, fix the coding. Well, we're not done, because what they changed could have damaged something else, and so they'll bring it back to us with a brand new fresh sheet, a brand new updated decoder, and they say, okay, get ready, start from page 1 again. And so it's a very time-consuming and a very tedious process as we work through there, because we want to make sure that we deliver you a product that you're confident in, that you know will not only be able to do what you want it to do, but also will stand the test of time, because we do endurance tests and things like that. But this software verification is also part of the process that we use to deliver you a decoder, so that way, again, you're not finding some booby trap or whatever that we built into the decoder later on. Because if you could break the decoder by changing CV values, we didn't do our job very well. And so we try to make sure that we deliver you a decoder that you can be confident in, as well as be able to relax, enjoy, and get the most out of it. I mean, experiment. There's a lot of great features built into the Tsunami 2 and the Blunami that give you so much flexibility when it comes to running your trains that, it's really unmatched. And so therefore, you really can get in there and dive into there with that confidence. Now, the last thing I'll say is because, as I mentioned, we do actually manufacture here. And so when it comes to delivering you a quality product, we do actually hand test every single one of our decoders that leaves our factory. That includes all of our motor decoders. That includes all of the decoders that go to our OEM partners, such as Athearn, Bachmann, and others, that every single one of those decoders goes through that hand test. And the reason is because, again, we want to make sure that you're set up for success with your installation. And so therefore, if we relied on you to become our quality control department, for example, or uploading or downloading, whatever term you want to use, all the sound files and the software, that means you couldn't test the software to make sure it works. You couldn't test the hardware to make sure it does what the software is supposed to do. And also that makes you the end of the quality control if you have to do all of that stuff, because quite frankly, it's easy to just turn out decoders and ship them out blank and let somebody else be the problem. But if we find a problem on our manufacturing floor, we actually go right out, fix the decoder, repair it, whatever needs to be, and put it back into the production build. And depending if it's too catastrophic, obviously we can throw it away or toss it. But for the most part, they're easily repairable, and we have a very, very trained, well-trained staff downstairs that is able to make these decoders and make them with such high quality that you have known from SoundTraxx, so that way when you open the package, you're getting a good decoder. But unlike every other thing, when you press the brakes the last time they worked, you press the brakes the next time, something could go wrong. But we do try to eliminate all of those. And so there's always that possibility. So if you do run into any issues, contact our support department. Graham, who's now running our support department, has actually been doing really, really good. And we expect a lot of great things from him. And don't fret, viewers and listeners. Graham will be on here before too much longer. He's still trying to get his feet wet and get some comfortability going, but he'll be back. He'll be joining us before too much longer. So, but anyway, the point of all of that is that we try to build a lot of that quality into the product, so that way, when you buy a SoundTraxx product, you know you're buying something manufactured here in the United States. You have a product that's been thoroughly tested to make sure that you're not going to find the bugs or the problems or anything like that. And that's the extra level of effort that we put into it, again, because we're modelers ourselves, as evidenced by things here in front of me and that we've been talking about over the past several podcasts. But we're modelers ourselves, and so we know the frustrations that you as the modeler can encounter with random electronics that may or may not work. There's a lot of stuff out there, especially over the years, where let's say you try to push the button and select the CV, for example, that is the wrong value, and it puts your decoder into vapor lock. Well, now you break it. And so what happens, you have a lot of people that are afraid to make any changes because they don't want to break their decoder. They just spent money, and they just spent a lot of time putting it in. And so that's why we build the confidence into it. But for those of you who are new to this and you haven't done the installations, be sure to check out our SoundTraxx installation guide that you can find on our manuals pages on the website at SoundTraxx.com. Because in the installation guide, there's a lot of great tips to give you some ideas and confidence with how to do the installation and how to perform it. One of the biggest things is when you're using a board style decoder, that you go in and actually use the correct type of solder flux when you're making your solder joints. Not everything is the same, and you can't go to the Home Depot or the Lowe's or whatever your box hardware store is and pick up soldering materials, come home and work on the microelectronics. That's a recipe for disaster. But we try to give you all the tools you need to be successful in your installation, because again, when you don't have a fear of the electronics, this hobby becomes a lot more fun. And that's one of the things I'm a big push of, is education. And many of you guys have known that because we've been doing our YouTube channel for so long. We push some topics on these podcasts, things like that. Again, all designed to help make it fun and educational for you as the user, because knowledge, as what they say, is power. And when you know something, you're not afraid of it. And so we've been giving you a lot of this information. We have our users guides out there. And the idea behind all of that is so that you have the information so that you can do as much or as little of the adjustments or settings that we build into the decoders as you desire. You're not limited by your fear or your apprehension, getting in there and going, oh my gosh, I've got a locomotive running, I'm not going to tempt fate. You don't have to panic, because there's a lot of stuff in there and you can do as much of as little. So let's say, for example, with this locomotive, if I don't know how to set up all the lights, let's say I decide I'm going to wait for lights, I'm going to play with the motor, get that running, get the address set and so forth, so that way I can worry about the lights at another time. Great, run it as much as you can, and then just make sure you go back, because if you limit your enjoyment because you're afraid of something, or afraid of setting a wrong value, then we kind of limit ourselves a little bit. And I get people will ask me a lot of times, especially when I bring my stuff to run, they'll say, your stuff sounds so amazing, it runs so well, what did you do? And my standard answer typically is not anything that you can't do. There's no secret squirrel CVEs or anything like that that's not published. I'm just taking the time because, well, obviously I do this for a living. I'm aware of the features and so forth that's built into the decoder, so I jump right in. But the point of my comment is not that I'm hiding some secret or anything like that. It's that things that are worth doing, for example, getting your models running like this, are worth learning and taking the time to learn how to do it. Because, kind of in another example, as I've had people come up to me at shows and tell me that, man, they love the SoundTraxx products, but they don't like the fact that it starts up as soon as you put track power. And my comment to them was, I've got over 500 CVs. Did you not even look at the manual to find out that that's just a setting? As you can see, these locomotives are sitting here, sitting still and being quiet, even though track power's on. Because they don't auto start, because I've disabled that. It's just a setting. But my point of all of this is that if you want the decoders and the locomotives to behave a specific way, I would say the chances are that the settings and the features exist in our products. It's just a matter of taking some time and reading the manual. And I realize that's a challenge because a lot of modelers don't want to read the manual. But please, at the very least, I've said this before here, please read Chapter 1. Chapter 1 will give you all the information you want about how the decoders are set up, all the sounds that you're hearing. So when you hear sounds on the locomotive, you know what you're listening to. It's not just some random noise that plays in the background that you're like, well, they must have done their research. It's just some random noise. Know what it is, because then it enhances your appreciation of what actually is going on. And so, for example, and like I said, anybody can make a noisemaker, but when you use your brakes more frequently, which is the function 11 by default, again, you can move it anywhere you want, but the function 11 braking, when I use the brakes more frequently when I'm doing my operation, my decoder is sensing that, and it actually will trigger the air compressor to cycle on and off as you use the decoder. So it's just another example of how using your decoder can trigger certain sound effects, as opposed to you having to push the buttons for air compressor low and air compressor high, so that way you're simulating all the sounds the engine would be doing, but you're having to push all these buttons to do it, which again, most people don't get to. Most people blow the horn, ring the bell, and run the locomotive, turn on the lights, and they want a lot of that other stuff automated for the most part. And so our decoder allows a lot of that to happen. And you can have certain things like triggering the brake squeal as you reduce the throttle or whatever the case is. So it's really up to you. So again, dive into the decoder, learn about it. And these are the features that we built into the decoder here that we think far enough in advance. Let's bring it back to center again here. But we think far enough in advance so that any features that customers have asked me over the years, the Tsunami 2 can already do. And so therefore it's just a matter of not checking out the manual. And that goes back to the very first step. What do we want the decoder to do? How do we want the decoder to behave? And that's where we sit down and write a spec out so that our software engineers can basically write the code to tell the decoder to behave as we want it to do. So that's kind of a long-winded, for example, explanation of how we build our decoders from scratch. And then maybe we'll do another one another time about how we do our audio sounds, where we get our recordings from and things like that. Because when we work, it's a lot different with working with the railroads than walking around in a field with a microphone hoping to get the right sounds. And you certainly can't do a lot of sounds, for example, a diesel engine, from having it pass you. So stay tuned for that explanation in a future episode of Sound Bites. Now I'm going to shift gears here a little bit. I'm going to take a drink of water. And I'm sure you see these models over here and you're thinking, talk about the models. That's the fun part. Okay, let's talk about the models. So these are some of the newest upgrades that I have just gotten done. I did a lot of these over the holidays. And one of the features, of course, of all of this is adding the lights. I can simply install Blunami decoders into them and have them work, but really you want to have a lot more of those light features built in. And so on this one here, now I'll start with this lead unit, or, well, I guess either one could be the lead, but we'll start here. And this is what the Missouri Pacific called an SD40-2C, and the C stood for coal. And the reason is because these locomotives, as you'll notice, have dynamic brakes. Most of the Missouri Pacific didn't. They were more or less a flatlands Granger railroad, and they didn't need dynamic braking. But these first 20 units, originally numbered in the 3200 series, and then in the 75, 76 renumbering, they were put into the 6000 series. But these first 20 units came with a full Rio Grande style lighting package. So you had the nose lights, you had a rotary beacon on top, in addition to the headlight and all the other traditional lights. And the reason was because with the explosion of coal from the Powder River Basin, a lot of railroads were running out there. Burlington Northern was transferring stuff down. Rio Grande would transfer stuff down, and then they would also transfer to the Missouri Pacific, things like that. So these were designed as interchange so that they could basically build a consist, send it along the way, and the other respective railroads would then run that train up to the Powder River, load the train, bring it back, and it would be delivered to the Missouri Pacific. But if they didn't have the dynamic brakes, the other railroads would basically take that stuff off and put their own on because they were running through the rugged Rocky Mountains. Especially the Rio Grande, interchanging in Pueblo, would take that from Utah and come down Junction and all those type of things, and come down over Tennessee Pass and then deliver to Pueblo, where the Missouri Pacific would then take it east towards the other power plants throughout the entire line. So this one here is an Athearn RTR out of the box, painted this way and so forth. Like I said, I went in and did a bunch of the lighting, weathering, stuff like that. Added a crew in the cab. Sorry, can't speak. And then one of the other things was, again, as I mentioned, to light it up, and then of course put Blunami in there. Now, one of the other things that's really neat about some of the Athearn stuff is these plastic fuel tanks. The way they're mounted in is you have a weight that kind of drops down in the fuel tank, but then that curved section of the fuel tank is basically vacant. And so you can put some extra lead shot or moldable lead, or even some of that Cerobend type low temperature melting metal that you can just pour into the side there and create a weight that would live in the side. And the Cerobend is a low temperature melting weight material that you can put in there that doesn't attack the plastic because it's melting at a lower temperature than the plastic does. So you can use it to fill voids like that with just some weight. So take a look at that out on the world. And so I've added that kind of stuff. But we'll go ahead and just show you. I've got camera 2 sitting over here. We're going to go ahead and open the functions. Now, I haven't fully named everything. I'm using the Android tablet here in front of me. Now, I haven't gone through and named everything. Now, on my phone, where I operate at home, these are all named and everything else. But when we go to the functions over here, we've got our 6009. You see that the function menu is out to the side. Now, I'm partially covering the 3039, but watch, I can tap on the name and it'll move it over to this blank space. So now I can actually see the operations or throttles for both locomotives. That's a personal choice. But when we hit 15 to 28, you can see I have a couple of these labeled. I have the rotary beacon, which will start up here. Then we have the Mars light. Now, one of the things you'll notice on this Mars light is, well, wait a minute, you said it's a Mars light, it's not flashing. That is correct. Because what I've learned in my research, talking to some old Grand Hoggers and even Missouri Pacific people, the Missouri Pacific never really used these in their own railroads, so they only really used them in interchange. But some of the Rio Grande stuff, the nose Mars light wasn't just a constant flashing. And so the Missouri Pacific being built towards those specs, what it does is it actually will trigger when you blow the horn. So when I come over here to blow the horn, now you start to see that Mars light take effect. And as long as you hear the bell ringing, you'll see that Mars light coming into play. And then once that's done, then the light will go back to a solid light. And so that's one of the ways that you can kind of experiment and play with how you set your decoder up. But anyway, other lights that I've got on here, I've got the front class lights, which are over here. I've got the rear class lights, which are hard to see, but they're back here on the long hood. And then what's labeled as FX8 is actually my number boards. And then also I've got my truck lights or the ground lights down below. And I've tied those in together because normally, like in the case of this, if this was running, the train would be running this way. The front number boards where the engineer would be sitting would then also have the truck lights or the ground lights on. Now, the ground lights are there so that the engineer can actually look out the window, look at the ground in the dark, and see that the ground is actually moving underneath of them to find out how much or if they need to add any sand to get the locomotive accelerating. Because if you're in the cab and it's completely dark in some of those areas and you throttle up and you hear the diesel engine throttle up and the engine starts moving back and forth and you kind of feel it, but it's not moving, well, then you're going to end up wearing either the wheels, the rail, or both. And so those truck lights, the ground lights, are there to illuminate the ground so that the engineer can look out, make sure he's moving, and then either throw sand on it or throttle up, because now he's actually got the train tight. And so I put those on the same one. They don't need to be. I can certainly put them on separate ones, and so forth. And then, as I mentioned, we have our backup light, which is the rear light. And this is just one of the things that I've done with all of this. And right now I don't have anything assigned to the F27, and that would be because I don't have, on these Athearn RTR models, the rear number boards are not illuminated. And so that's a future project to get in there and cut that out and actually illuminate those on this model. But most of the time when these were running, they were running forward, so you really wouldn't have the number boards on the long hood illuminated very often. The other thing about the number boards is that you'll notice that I have the clear lights on the class lights, and that's because in the Missouri Pacific era that I model, everything was run as an extra. And so the clear light would indicate that this would be extra 6009, so that any trains waiting for extra 6009 on their train orders would know this is the train they're waiting for, and then that would go. Now, if they have another train coming behind, the train order would probably say wait for extra number, I don't know, I'm making up a number here, 1572 or whatever, and so the engineer would be sitting there, see this train pass, and know that's not the train you're waiting for, because this is 6009, not 1572. So the engineer on the other train sitting in the siding knows that's not my clearance. And so when that train passes, he waits, and then he sees another train coming. Then he has 1572 on the number boards. He says, yep, this is my train. Once that clears, now he's got clearance. He can go down on the main line and head down wherever it is that he's going, whatever job he's got to do. And so that's why I focus more on illuminating these. Now, I will tell you that the Athearn the cabs that have the positionable windows for sure. This one actually had it as well, but these windows aren't positionable yet. So you have to double check. But for sure, the ones with the positionable windows, that cavity behind that number board plate is hollow. So if you just pry that number plate off, and it's just held in there with some, tacky glue, you peel that off, you just drill a hole, put an LED in there, and you can mount and light the number boards. The only challenge is what they did was they printed the white lights, or I'm sorry, the white numbers on the plate, and then they painted the whole back behind it black. So it doesn't really illuminate well with a solid black plate. So you kind of either have to sand it very, very gently to reveal the white paint for the numbers, or what I've been doing is just scratch the whole thing off and then make a decal and put it on the front of that lens and then put it into the number board, which you can see here. And the font you can get, if you go to the Baltimore and Ohio Historical Society page, they actually have the EMD number font that you can download into your Word document or whatever your document, whatever decal making software you have, and you can then just use that to make number boards very, very easily. So you can mount the LEDs inside there, and then now what I do is then I'll print it on white paper. So the white comes from the number or from the decal paper. The black is printed over by the printer, and then I just cut it to fit and glue it on and secure it to the front of that lens, and then mount the lens back in. So it takes a little bit of effort. One of the biggest challenges that I have when I'm doing a lot of these light upgrades is just waiting for glue to dry. Because I've done some videos in the past, you can see on our YouTube channel where I did how I added class lights to my GP7 Missouri Pacific, and you can see there's multiple layers of paint that have to wait to dry before you can apply the next paint and so forth to get a nice, good, clean effect. So that's the first locomotive I did. The second one here is, again, it's another standard Athearn RTR. This is a SD40, just a regular SD40, and it's also, like I said, without the dynamic brakes on it. And I basically did the same thing. We've added the number boards, the class lights, the truck lights on the front. This is my most recent completion here. And again, both of these are equipped with Blunami, so as you can see, they're connected to the app here on the screen. And if I want to run this guy, you can see I push the function button, and on the screen you can see that change. And I haven't gone through and named them on the Android tablet here yet, but I've got access to this, my bell. Everything I can do through the Blunami app is being sent to the decoder, and the decoder is creating the command and doing what the app tells it to do. So this is a fun project, and if any of you guys caught, you probably saw this one in the layout tour, which was our last episode of the podcast, pulling the coal train. I thought that was pretty funny to have a SD40, one coal car, and a caboose. It's technically a coal train, so why not? But also one of the other things here, and I'll bring the other camera over to show, is I've been installing these Magnalock brake lines and the MU cables. So in between the two, these are just magnetic. And so you can see I pull this off, and that's just a magnet that holds it into place. And so I can come in here and add an MU line really, really quick and easy. And then, of course, when we uncouple the locomotives, we're going to take that away. Now watch the brake hose. When it pulls apart, it separates. And the magnets on the end are ready to join again. And there you go. And now they're ready to go. And we put in I put in my MU cable. If I can get the other end of this. My fingers are not cooperating with me while holding the camera. And there we go. But let's put it down this way. So you can see how easy this is. Now these brake lines and the MU cables are made by North American Railcar Company. They are also a SoundTraxx retailer, so be sure to check them out. But they are based in Canada, and I can't get my hands to cooperate. There we go. They're based in Canada, but give them a call or an email and take a look at these things. They're pretty dang cool, and I've been in the process of upgrading all my locomotives to have these, and then at some point in the near future we'll also upgrade the air hoses to all my rolling stock, so that way I have the air lines connected through the entire train. So with that, we've run a little bit longer than I had planned, so I'll kind of wrap this one up. This is another episode of our Train Talk from Milepost 141, the SoundTraxx Sound Bites podcast. Hopefully this was entertaining and informational for you. Like I said, stay tuned. We got a lot more stuff to talk about. We've got some guests. Geez, I can't even speak anymore. We've got some great guests coming up in future episodes, so be sure to check those out as well. And we look forward to seeing you guys next time. If you have any comments, be sure to like this video and leave a comment for us. Let us know what you're thinking. If you guys are watching this, if this information is helpful for you, or if you'd rather talk something a little bit different about, I don't know, more about the models or whatever you want to talk about. Like I said, shoot us a line, let us know. We're always open to entertain you guys and to help make model railroading more fun. So with that, we'll close this out. We thank you guys for watching, and we'll see you guys next time.